In this video, we will investigate several more examples involving the chain rule. The first of which is going to be to find the equation of the tangent line to the curve 1 plus 2x raised to the 10th power at x equals 0. So since we're asked to find the equation of the tangent line, and this is at x equals 0, I will remind you that that equation is given by if we let 1 plus 2x to the 10 be the function that we call f of x, the form of the tangent line will be f prime of 0 times x minus 0 plus f of 0. And as you can see from the many such examples we've encountered, remembering the form of this tangent line really is key. This indicates to us that we have to do two things. We need to first find the function value f of 0, which should be the easier of the two things, and then find the slope of the tangent line, f prime of 0. So let's go ahead and find the function value first. So f of x is 1 plus 2x raised to the 10th power. So f of 0 is 1 plus 0 to the 10th, which is 1 to the 10th, which is the number 1. So we've taken care of the function evaluation. The next thing we have to do is differentiate. Now, notice the function that we need to differentiate, 1 plus 2x raised to the power 10. This is something that we can very conveniently differentiate via the chain rule. We take the derivative of the outside function, so that is the 10 comes down front, the new power is a 9. We evaluate at the inside function, and then we multiply by the derivative of that inside function. So 10 times 1 plus 2x to the 9th, and the derivative of 1 plus 2x is going to be 0 plus 2. So we have 20 times 1 plus 2x to the 9th. So f prime of 0 is 20 times 1 plus 0 to the 9th, which is 20 times 1 to the 9th, which is 20 times 1, which is 20. So the slope of our tangent line is the number 20. Putting this together, we have that the equation of the tangent line is y is equal to 20x plus 1. Now, let me make an observation. In this problem a moment ago, we used the chain rule to differentiate something that was of the form g of x raised to a power. Now, regardless of what that function g of x is, as long as we can differentiate it, we will do so using the chain rule. So you say you take the derivative of the outside, so n, and then the new power is n minus 1. We evaluate at the inside function, and we multiply by the derivative of the inside function. And note that this much more general looking formula is exactly what we applied above with the chain rule. So it's something that we want to get used to, and it's really, once again, a bit of pattern recognition that comes along with this. So let's find the equation of one more tangent line to the curve sine of sine x at x equals pi. So because we're asked to find the equation of the tangent line, let's write down what its form will be. So if we let this sine of sine x be our function f of x, it's at x equals pi. So y is equal to f prime of pi, the slope of the tangent line, times x minus pi plus f of pi. So we need to do two things once again. Determine the function value f of pi and find the slope of the tangent line, f prime of pi. So let's first take care of the function evaluation. So if f of x is sine of x, that tells us that f of pi will be sine of pi. Sine of pi is a common value. It is 0. And 0 is also a common value of sine. Sine of 0 is 0. So the function value f of pi is the number 0. Now we also need to determine the slope of the tangent line. So we're going to have to differentiate our function. Well, sine of sine x, we need to use the chain rule. You have an inside function sine and an outside function sine. In words, what we do is we differentiate the outside function. The derivative of sine is cosine. Then we plug in the inside function, sine, and then we multiply by the derivative of the inside function. So we multiply by the derivative of sine. And if you want to immediately, instead of writing derivative of sine, just replace it with cosine, that's perfectly fine. I just want to make sure that, as much as we possibly can, you see exactly what we are doing step for step. So this is cosine of sine multiplied by cosine. And we need to know what is the value f prime of pi. So replace both of those x's with a pi. So sine of pi and cosine pi are common values. Sine of pi is 0, and cosine pi is -1. Cosine of 0 is also a common value. Cosine of 0 is 1, and 1 times -1 is the number -1. So we've determined the slope of the tangent line. So the tangent line is y is equal to -1 times x minus pi, which is more conveniently expressed as -x plus pi. Another similar type of problem we can do is to use the chain rule to write down what the derivative will be in terms of some unknown function big F. So the idea is to assume that big F is some function that we can differentiate, and we want to write down this derivative in terms of the function big F. It's a composition. You have the outside function big F, the inside function 1 plus x squared. So in words, the chain rule tells us to take the derivative of the outside, so that would be big F prime, evaluate it at the inside, 1 plus x squared, and then we multiply this by the derivative of the inside. And the derivative of 1 plus x squared is 2x. And just to make sure we all see what's going on here, that 2x was the derivative of 1 plus x squared. But hopefully at this point we're becoming comfortable, extremely comfortable I hope, with differentiating expressions such as 1 plus x squared. It's the derivative of 1, which is 0, plus the derivative of x squared, which is 2x by the power rule. So similarly, to differentiate this second expression, we see that it's kind of this general form that we had earlier. We can think of this as being g of x squared. So what we do is we differentiate that outside squaring function. The 2 comes down, the new power is 1. We evaluate at the inside function, and we multiply it by the derivative of the inside function. So we have 2 times 1 plus f of 2x. And when we differentiate this inside function, we say, okay, the derivative of 1 is 0, and the derivative of big F of 2x. Well, big F of 2x, that's very similar to big F of some function that we've differentiated above. So by the chain rule, its derivative would be what? The derivative of the outside, evaluated at the inside, times the derivative of the inside. The derivative of 2x is the number 2. So this would be times f prime of 2x times 2. And simplified slightly here, it would be 4 times f prime of 2x times 1 plus f of 2x. So another observation to make is not only can we use multiple methods in the same problem, it's very reasonable that in a problem we'll have to use a chain rule not only once, but also a second time.